Good. You can hear me, right? If you have any issues regarding the audio or the video, send a message to the chat, right? Chat message. Okay, then let's start today's session. And today we will be starting the fifth unit, right? The energetics unit. And before starting the fifth unit, I will give you a few I'll give you a small idea on how this unit is going to happen and how long this unit is going to be continued. And as usually, we normally inform our further plan until your syllabus is finished whenever we are starting a new unit, right? And from here onwards, what is our plan? Everything will be informed before starting today's unit, right? And finally, I will before every day, starting every day, I will inform the entire plan for a session before we start the day. The other plan I'll inform you, right? At any time, if you have any doubt, if you have any issue, if you want anything to be clarified, doesn't matter whether it's something related to chemistry or some related to any other announcement, just send a message to the Zoom chat, right? That's what I want from your side. Harida? Okay. Then okay. Then I think everything is fine from my side, so I'll start. Hari? Right. So today we will be starting the fifth unit. This is the final small unit, as we name it in our syllabus. We have 5 small units, and afterwards we'll start the actual chemistry parts, which is inorganic, organic, and then equilibrium, right? Those 3 are the main units. So the first 5 units are the building blocks of your syllabus, which has relatively smaller amount of marks when it comes to your paper directly, when it comes to A-level paper directly, but a significant amount of marks indirectly using the skills which you learn here, right? So for an example, I hope most of you have learned the third unit. Directly for the third unit, you get a very low amount of mark, but indirectly for inorganic, organic, equilibrium, chemical, for kinetics, everything, you will require the third unit knowledge. So this unit also, the fifth unit also is something like that, right? So today, from the beginning, so we are starting the fifth unit, and we will be continuing the fifth unit for roughly 6 to 7 weeks, right? Which means by the end of April or in the middle of April, we will be finishing the fifth unit, and then we will be starting inorganic, right? And I'll explain the entire structure about the fifth unit later. And before that, our plan, the schedule for our class until next year February, until 2026 February, will be something like this. So I'll just explain it briefly. I'll send the schedule later to the group. I have sent it previously because it's important to inform what we are planning, because on the first day of a unit there are new students, so I always repeat it, right? But can't tell. So according to plan, today is March, right? March, we will be starting the fifth unit. Then that will be continued to April. Then we have inorganic. We have inorganic, which is the sixth unit. I'll write it as inorganic. We have inorganic. Then we have organic, which is this is the sixth unit. This is 7, 8, 9, 10. And then we have a unit called kinetics, which is the 11th unit. Then equilibrium, which is the 12th. Then electrochemistry, which is the 13th. And finally industrial chemistry, right? Industrial chemistry, which is the 14th unit, right? So this is the entire syllabus from here onwards. Now there can be students with issues regarding the first 4 units. If you have any issues regarding the first 4 units, we have arranged special programs to cover those units. We actually did arrange special programs. So in our classes, the specialty is once we cover an entire unit, we will arrange a revised program. So for the first unit, second unit, third unit, we have already arranged those revised programs. So we have entirely covered the unit, and we have also arranged the revised program, and that has also been finished. For the fourth unit, we haven't done anything yet because it was finished last week. But very soon we will again arrange another program for that as well. That's another story. Now here, so this is the entire syllabus, and these 3 units are the main units: inorganic, organic and equilibrium, right? Inorganic, organic and equilibrium. You can forget about this industrial chemistry because that is done through a special seminar series, because that's a little bit different. You will understand that later. So for the moment, when you are planning the unit, when you are planning for chemistry, you can forget about it. Therefore, we need to plan. We have made the plan until electrochemistry, and then roughly inorganic will be done for 3 months, organic will be done for 3 months, and equilibrium will be done for 4 months. Kinetics and electrochemistry will be done parallelly while doing these 3 main units. So roughly kinetics will be done for 6 weeks, and then 6 weeks, 1.5 months. Then electrochemistry will be done for 6 weeks, right? So those 2 will be done parallelly, which is 3, 6, 10 months. Here 10 months. So if you add 10 months for April, from April, if you count 10 months from April, it will be roughly end of January of, so you have 8 months here, end of February next year, right? So that will be the plan. So from here onwards, still we are continuing our plan, which I introduced you when we started the class on I think last October, and we will be finishing the entire unit in next year February, right? That's our plan. So we are on track. I hope that's clear. So you need to be properly aware of what, when, how we are doing the syllabus, right? So that's really important. So that's the number one thing you need to know. All the students and the new students should be properly aware of the progress of the syllabus, right? Make a clear, make a. So this unit, the energetics unit, will be done throughout March, and sometimes I might take the entire April, so sometimes I might not. It depends. Hari April වල මැද්දේ holiday එකක් එහෙමත් වෙනවානේ. පොඩි කතන්දර ටිකක් තියෙනවා ඒක, right? Okay, so that's it for the syllabus. Syllabus එකට එච්චරයි. And also we will be starting our paper class on this month, which will be announced later. Hari මම මේ කියන්නේ normally the common questions new students ask us before starting a unit, then that's easy from my side, right? මම ඒක ඕනම unit එකක් පටන් ගනිද්දී I'll explain the most common questions. When do you finish the syllabus? So I answered that. The second question is that are you starting paper classes, or do you have a paper class? So we are starting one on this month. Everything will be informed on the relevant groups, right? So that's it. And regarding the tudes, the final explanation, for each and every unit you will get a tute like this, right? You will get a tute like this. This is for the 4th unit, which contains only questions. We won't give any theory units. We aren't giving any theory tutes. Everything will be written. ඔයගොල්ලෝ ලස්සන clean short note එකක් ලියනවා, and that will be your theory note. But for each and every unit, we will give you a question book. That's a workbook which contains the MCQ questions, structured essay and essay questions. That will be delivered, right? That will be delivered because this is an entirely online class. There's a separate procedure. Generally on the 3rd week of a new lesson, we will be delivering tutes, right? So that's the entire idea. හරිද? ඕක තමයි generally those are the most commonly asked questions by new students. So I hope I explained those properly. If you have any doubts regarding those things or anything else before we start the unit, you can ask. හරි. ඕවා ගැන මොන හරි ප්‍රශ්න තියෙනවා නම් you can ask. And anything else or මොන හරි තියෙනවා නම් you can ask. If not, we'll continue. I'll explain what we are doing today and the entire plan for the 5th unit, and then everything. Then we can start the lesson. හරි. මම මේ පොඩි introduction එකක් ගත්තේ until students join. දැන් මම හිතන්නේ හැමෝම join වෙලා ඉවරයි. So we can continue from here onwards properly. මේ මොන හරි අහන්න තියෙනවා නම් අහන්න. And also we have another theory class for 2026 batch if you are interested. That's happening physically and online both, and that's from 9 a.m. to 12 noon on Saturday, right? And this unit will be starting on next Saturday on that class. Sorry, එහෙම එකකුත් තියෙනවා. Any questions? මොන හරි ප්‍රශ්න තියෙනවා නම් අහන්න පුළුවන්. මොනවද තියනවද? Nothing. I'll give you 10 to 15 seconds. If you don't have anything, you can continue. Always, if you have a question, you can even text me on WhatsApp. I won't be replying those most probably, but you will get the answer. If you want anything to be answered by myself, you can ask now. Nothing. Saved. උත්තර ටික හම්බුණා. Okay, so I think there are no issues. ප්‍රශ්න නැහැ වගේ. හරි. Then before we start today's work, so this is the only day, always the first day I will be talking a little bit. හරි. මම පළවෙනි දවසේ චුට්ටක් කතා කරනවා because I want to be familiar with you. You need to know me, especially the new students. හරි. තව මෙතන ඇති some students who joined for previous units but didn't continue that unit and then they realize that they are supposed to somehow start to work and ඊට පස්සේ join වෙච්ච අය ඇති. එහෙම එක එක જાතිය කට්ටිය ඇති. Therefore I make sure once in a while, so roughly once in 2 months, which is when we are starting a new unit, I'll explain what's happening here, what we are doing here, right? එතකොට ඉතින් අර for the students who are joining regularly, it might be a little bit disturbing, troubling එන්නේ නැති මේ එකම එක කියද්දි කරන්න දෙයක් නැහැ, right? So ignore that. Is there any question? The payments. Is the Saturday class English medium? Yeah, the Saturday class is also English medium, but the difference is that it's like we will be using like 50 Sinhala and English, right? I mostly use English, and when I'm teaching, I'll always use entirely English, right? So if your mother tongue is not Sinhala, you need to join today. If your mother tongue is Sinhala, but if you are doing English medium, you can join today or either Saturday. Doesn't matter, right? Again, on the Saturday class, we use both languages. Ek preferences තියෙන ළමයි ඉන්නවා. That's why we have two types of classes. So in this class, we will be using entirely English. On that class, we will be using both. That's the difference. And about the payments, details will be informed to the group, right? How to make the payments. The payment is 3,000 per month, right? And about the payments and how to make the payments, and there's a website registration, everything will be informed on the group. So always you need to make sure that whether you are on the WhatsApp group and whether you go through all the messages. I normally repeat the messages. My message I'll send it at least twice to the group. Everything will be properly informed. Bigger messages, anything can't help, but you need to go through those. Sorry. Right. වෙන මොනවාරි ප්‍රශ්න තියෙනවද before we start? Nothing. මොනවාරි තියෙනවද ප්‍රශ්න? Is there any student who hasn't finished the 4th unit but joined for the 5th unit? I just want to know you students. That's why. කවුරු හරි ඉන්නවද? So now the new students have definitely going to another class. Now if you join today for the first time to see what's happening here, you might be going for another class. Is there anyone who hasn't finished the 4th unit but who is here today? Always try to respond me, because this is entirely an online class. I am just looking at a camera. It's boring. I always want your responses, right? ඔයා හැමතිස්සෙම මට උත්තර දෙන්න. Then that's fun. Actually, the teaching process is fun for me then. හරි. Physical classes doesn't matter. ළමයි කෑ ගහනවා. It's kind of interesting. But online classes are boring. From your side also, it will be boring once I start teaching, right? It's the normal way of online class, right? So make sure to always communicate. හරි. Whenever you have a question, put it on the chat. Alright. Whenever you want to make a comment, put it on the chat. Doesn't matter. අවුලක් නැහැ. හරි. කිසි ප්‍රශ්නයක් නැහැ. I haven't finished. Okay. Okay. Right. So there are a few students who haven't finished the 4th unit, right? Okay. So if you want to finish the 4th unit, you can get the recordings. No need to make a separate payment if you are joining our class. If you are continuing our class, that's a separate facility we provide. If a student join from the 10th unit, all the previous recordings will be given. But that's how it is. I always will give the previous recordings. Then the next thing is now, is there anyone who has done the 5th unit previously? Who does know another class which is doing the 5th unit for 2026? I don't want the name of the class. I don't know who is doing the class. Does anyone know another class who is doing the 5th unit? Where they are doing the 5th unit? Most probably, there can be. I don't know. But I want to say that we are continuing in a sort of a significant pace, right? අපි ටිකක් වේගෙන් යනවා. That's why we are doing the 5th unit now. That's why we are finishing the syllabus on February next year, right? අපි භාගෙට උගන්වන්නේ නැහැ, but we are doing it in a some sort of a space. ටිකක් වේගෙන් කරනවා. Therefore, it's your responsibility to somehow catch up. Right? Because I am maintaining a certain standard, you need to be able to somehow try to match it. So if you feel that you are not that strong, you can go through the recording because you are 2026 students. You should have time. You should be able to commit. ඔයාට වැඩ ගොඩ ගහලා තියෙන්න බෑ දැන් එද්දි. Therefore, you can either get the recording, you can go through it again, you can ask questions. Somehow try to match my pace. Then if you succeed, you will be able to finish the syllabus in February next year. Then you will have a massive advantage over the other students, right? I can guarantee that because you will have 6 months left to do all the papers, all the revision, everything, right? So we won't do the syllabus, අපි අර භාගයට syllabus එක කරන්නේ නැහැ for the sake to finish the syllabus quickly, but we are maintaining a certain pace, right? So make sure that you understand that. අපි අර ගොඩාක් හිමින් කරන්නේ නැහැ. That's not possible. That's not our objective in this class, right? I think that's clear. Right, then I think that's it for an introduction. අපි පටන් ගමු. Yeah. If you have any questions, put it on the chat later. හරි? And also sometimes the mic might not work properly. එකපාරට mic එක පොඩ්ඩක් track පනිනවා. Then put it on the chat. I'll fix it quickly. හරි? Because I don't know. I don't know your experience from your side. හරි? Right. Then regarding the 5th unit. Regarding the 5th unit. Another thing, I always forget this. Since this is an online class, always make sure that you are properly, you have prepared yourself properly for an online class, right? Make sure where you are sitting is suitable for a learning purpose, right? Make sure that your environment is properly maintained for an learning purpose, right? ඇඳන් උඩ sofa උඩ ඉඳගෙන you can't focus, then that won't make sense, right? That won't make any difference. Sorry, ඒකම කරන්න එපා. Then you won't understand anything. You will fall asleep. Right. එහෙනම් energetics. This is the 5th unit, right? You know that. We can divide chemistry into 5 parts, 5 sections. What are those 5 sections? Does anyone know? At least few. Ragal answered then. Still we are doing the introduction. When we are starting theory, I'll inform you. In our chemistry syllabus, we can divide chemistry into 5 parts. Yes, one is physical chemistry, right? One is physical chemistry. Good. I have said this previously. Physical chemistry. Yeah. We have inorganic chemistry. We have organic chemistry. Okay. And yeah, we have general chemistry. What's the other one? And industrial chemistry. Good. Done, no? You need to have this understanding. නිකම්ම කරගෙන යන්න බෑ. Right. This is the industrial chemistry part. Right. So we have physical chemistry, inorganic chemistry, organic chemistry, general chemistry, and industrial chemistry. We have finished general chemistry by now. General chemistry is the first 3 units. Right. This is the first 3 units. So which we have finished. That's the general chemistry part. And inorganic, as I mentioned previously, is the 6th unit. Organic is unit 7 to 10. We normally consider it as 1 unit. And physical chemistry, so this is the 14th unit, industrial chemistry, which I said not to worry. Then the remaining units will be physical chemistry, which is the 4th unit, the previous one, the gas laws. 5th one, energetics. Then the 11th one, kinetics. 12th one, equilibrium. And the 13th one, electrochemistry. Those 3 are the physical units. For most of the students, this part of chemistry is the most difficult. I don't know why. Maybe it's because you need to have some sort of a practice doing calculations. It might be the main reason, because first, if you are a student who is trying to do your A levels without a lot of practice, inorganic, organic, general might be okay, because you can make a short note. You can either borrow a short note and then somehow try to study a certain amount of theory, and then you can go and write it. So it's not that easy, but you can do something. But for physical units, if you don't understand the concept, not like O levels, if you don't, without understanding the concept properly, it's difficult to do questions. Then you won't understand anything, right? So physical units are the most difficult parts for most of the students, and out of those we have finished one, and we are doing the next one. Out of these physical units, in my opinion, looking at students' experiences, the 4th unit and the 13th unit are the most, let's say, the easiest units. Yeah, shape again, 4th and the 13th are the most, no, like 4th and the 11th. 4th and the 11th are the easiest. 13th is little bit difficult than that. In my opinion, 5th is more difficult than that. 12th is way difficult than that, right? So if I arrange this in an order, 4th, 11th, then the 13th unit is difficult, the 15th unit is more difficult, 12th unit is ගොඩක් difficult meter, right? So 5th unit has some depth. මේකේ පොඩි දේවල් ටිකක් තියෙනවා. This will be asked for your MCQs, for your essays, structure essay. This will be asked everywhere. So in your tute also, once you get your tute, you will see that we have questions accordingly. We have MCQs, essays, structure essay, we have everything. Right? So this is the idea on the unit which we are going to start. And now let's dig deep. බලමු මොනවද මේකේ තියෙන්නේ කියලා. What do we have under energetics? We can divide energetics to two parts. හරි. මෙයාව අපිට divide කරගන්න පුළුවන් to two parts. The first part is theory and the next part is calculation. That might be obvious. Right? Normally for a physical chemistry unit you have two separate sections, which is theory and which is calculations, but the difference in this unit is, now if you can remember, let's say the gas laws unit, we did not separate the unit into two parts, the theory and calculations. We did not do the theory first and then start doing the calculations. It was a simultaneous process, right? We learned one theory and then did the calculations for that. We learned another theory and then did the calculations for that. But here it's different. The structure of this lesson is different. First of all, we are supposed to learn all the theory. Then only we can actually do a calculation. The calculations are little bit different from a normal calculation. Now when I say a calculation, there is something which you recall, right? ඔයාට සාමාන්‍යයෙන් calculation කිව්වම හිතන දෙයක් තියෙනවානේ නේ. The normal definition of a calculation, it's different here. It's actually not a calculation, it's a mechanism sort of a thing. ඒ කියන්නේ පොඩි නිකන් under this unit we will be learning a mechanism. So once you input data, they will expect output. This mechanism will be learned under calculations. To learn this mechanism, you need to know a lot of theory. There are definitions, there are equations, there's a combination of theory. Is that clear? ඔන්න ඔය වගේ එකක් තමයි roughly වෙන්නේ. And according to our plan, we will be doing theory for 2 days. We'll be doing theory for 2 days. So that will be mostly theory. හරි පොඩ්ඩක් boring වෙන්න පුළුවන්. That's how it is. But we will be doing theory. We will be focusing theory and we will be finishing it quickly. Not 2 days, it might be 1.5 days. Let's see. And then we will be starting to do calculations. Now we have 4 or 5 mechanisms. Again, once you give the input, there are 5 ways which you can use to get the same output, like mechanisms. Podi vidhi වගේක් තියෙනවා. Right? That will be done in this calculation part. හරිද? So is that clear? අවුලක් නැහැ. Now you have a basic idea. You don't know what's happening here, but you know what we are going to learn. මේ පටන් ගන්න හදන වැඩේ ගැන you have a good idea. හරිද? Right. Okay, then let's start. Enough introductions. Now you have a basic idea. Put the topic energetics, unit 5. Put the topic energetics, unit 5, and then let's start learning. Hi. Okay, write the main topic. Write the first main topic. Write the first main topic. Main terms of thermochemistry. Main terms of thermochemistry. Main terms of thermochemistry. or thermodynamics. Both are not the same, but both will do. Thermochemistry. What's thermochemistry? Can anyone give an answer for what's thermochemistry? What do you understand when I say thermochemistry? So this is the first main topic. Always make sure that your note is written in a neat way. So when I say main topic, put a 1. Then when I say subtopic, you can decide whether it's Roman number 1 or A or whatever. We will be writing subtopics and subtopic of that. But always make sure that your note is properly structured, because we are maintaining a short note. Right? For all the lessons, normally we will take, let's say, maximum 10 pages without calculations. For calculations, we are writing a lot, but for the note, it will be a very small amount. That's a specialty in this class. Sorry. Related to heat, yeah, shape again. So thermo means heat, right? Thermo means heat. It's something related to temperature, right? It's something related to temperature, and if we are learning it under something which is related to chemistry, then you can say thermochemistry simply, right? Nothing very complicated. Okay, under that, under the main terms of thermochemistry, put a subtopic and write, let's say Roman number 1. Defining a system. Roman number 1, defining a system. Defining a system. Are there any students who are joining this class and who has classes before this class? So you are finishing, you finish a class and then come home and then join another class or even an online class. Are there students like that? ඉන්නවද? ඉන්නවා කියන්නේ එච්චරයි. මොකද නැහැ. Okay. When does your class finish? When does your class finish? Is it an online class? Physical class. Is it difficult? මහන්සි නැද්ද? Are you tired? No? Good. Okay. If you are not tired, then I don't need to motivate you. Tired the reason to have the class in this time is because we started this batch 4 months late. So it was difficult to find a time which students can join. That's why we are having this class in this time slot, to make it more convenient. Make sure that you are not tired. Right? If you are tired, just put it on the chat. I am tired. Then we'll see. Doesn't matter. Then the first one is what was the first one? Defining a system. Now, before I go through the theory parts, this is very important. This thing is very important. These definitions might seem very obvious. I think these are very obvious, not all, but some definitions might look unnecessary to even write. But believe me, these definitions will be very important when it comes to doing calculations. Here, defining a system. Now let's take a normal example. We just forget chemistry. Let's say we are talking about a cricket ground. Then, how do you know what area is the cricket ground and what area is the remaining area except for the cricket ground? How do we define it? අපි කොහොමද cricket ground එක identify කරගන්නේ? Any answers? Or else let's say your house. How do you know which area is your home or house and which area is the remaining area? කොහොමද අපි ඒක අඳුරගන්නේ? How do we define it? How do we understand it or identify it? Any answers? මොකෙන්ද අපි identify කරගන්නේ? Any answers? Yeah, by defining the boundaries. Is it clear? By defining the boundaries. Okay, now if you want to define a specific location or a specific area, the first thing you need to do is you need to define the boundaries. Inside the boundary will be whatever the thing which we are interested in, and everything else will be the environment, or we can say the surroundings. Is it clear? Now once you define a boundary, let's say this is a defined boundary and we are only interested about this area, this thing will be the boundary. This is the place which we are interested, and this will be the remaining area. Now in energetics, in thermodynamics or in thermochemistry, the most important concept is we need to figure out which area is which area we are interested about when it comes to the heat flow or something, because it's important. So the area which we are interested is known as the system. This is the system. It can be a playing ground, it can be your home, anything. This will be the boundary. This will be the boundary. And the remaining area will be the surrounding. Which means from here onwards, for every and each calculation, we will be interested about what system are we talking about, what is the boundary, what type is the boundary. We'll discuss. There are a few types of boundaries, right? Now when you are talking about the wall, for your house, the boundary is a wall. It can be made of concrete, it can be made of brick. So depending on the material or the substance, it can the properties will change, right? Therefore, there are few types of boundaries. Somehow the part which we are interested is known as the system, and everything else will be the surrounding. From here onwards, we are only interested about, now this is the thermochemistry, which means we are interested about something related to heat. Heat is a thing which is flowing from place to place. Heat කියන්නේ තනින් තනට යන කෙනෙක්. Then we are only interested about the heat exchange from this boundary. This is what we are going to talk under the topic energetics. That's known as energetics. With this heat transformation, with this heat flow, there will be an energy flow, there will be energy transformation. That's what we are going to learn. Therefore, first of all, we need to define what is the boundary and what system are we interested about. That's very simple. Is it clear? Therefore, under defining a system, draw a small sketch like this, and then mark the boundary, the surrounding and a system. Then we'll write a small note on what is exactly a system, what is the boundary and what is the surrounding. Okay, ටක් ගාලා දාගමු. මේ විදිහට තමයි අපේ notes යන්නේ, right? Very small notes with small graphs. ඔහොම යන්නේ. Okay, what is a system? Now put a small star mark, put system. What is a system? Okay, what is a system? An object which is being studied. An object or an area which is being studied. So these aren't very strict definitions, these are just general definitions. They won't ask definitions here, you just need to know what's a system, that's it. The system which we are, the area or an object which we are analyzing. Now you can't write the definition of system, you can't write system and under the definition you can't say a system which is being analyzed. Why can't you write like that? Now that's a very common mistake students do. That sounds better but you can't write it. Why? Can you write under system a system which is being analyzed? Can you write like that? No, why can't you? Because when you are defining a term, in the definition you can't have that term, then that's not a proper definition. Therefore you need to find a substitute word, right? Therefore system, under system, right, an area or an object which is being analyzed or which is being studied, doesn't matter. Then it's easy. Is it clear? Harine? No need to write what I say exactly. You can write your own definition. Always try to write answers. That's the important thing. For most parts, I'll explain and expect you to write answers. That's system. Then, if that's okay, the surrounding. What's the surrounding? Simply everything except for the system in the universe. Everything except for the system in the universe is the surrounding. This is the object or an area which is being analyzed, and everything except for that system is known as the surrounding. Anything of the shape? You just need to write a brief explanation. If you have your own answers, you can send it to the chat. Some students are actually doing it. Then I'll say whether it's okay or not. That's surrounding. Then the final one, the boundary. What's a boundary? What's a boundary? Boundary is the border which separates the system from the surrounding. Now again you can't write boundary is the boundary which separates. Then again you will include the term. Therefore you need to find another term. Boundary is a border which separates the system from the surrounding. Is that clear? Shall we move on? Whenever we are doing theory, we will quickly move on. නැත්තම් කම්මැලි වෙනවා. හරි ටක් ගාලා යන්න ඕනේ. That's the first Roman number which is defining a system. Then put the next Roman number and write. Put the next Roman number and write. Now does everyone understand what's a system, what's a boundary and what's a surrounding? Always, if you want to check whether you have properly understood the concept, the easiest or the best way is check whether you can explain it to someone, right? If you can explain it to someone, then you have perfectly understood the concept, because having a doubt in your head, you won't be able to explain it to someone. Now whenever I have a doubt, I always check it before starting a class. No matter how much I know chemistry, if I have a doubt, maybe what I know is correct, I don't know, but if I have a doubt, I am not able to deliver it properly. It's common for everyone. Therefore check whether you can teach it to someone. Even you can do it practically in your home. You can teach it to your pet or your mother or your sister or brother. Or if you have a whiteboard, you can just teach it to the whiteboard. Those are good methods of understanding whether you have got the logic properly. You have time. Especially the 2026 students, try to figure out the best way to study for yourself. Because it's a case by case scenario. So it's not just looking at the book and just reciting it and expecting everything to be understood. You can try various methods. That's a self-study. Then the next part, the second part, types of systems. Types of system. Types of systems. Types of systems. Types of systems. Okay. Under types of systems, we have three types of systems. We have three types of systems. Those three have been categorized looking at the energy exchange and the mass exchange through the boundary. There are systems which can exchange both energy and mass from the system to the surrounding. Now let's take this. If you can remember, this is the system, this is the surrounding. If a system can exchange mass and energy both through the boundary, then that's one kind of a system. There are some systems which can only exchange energy. There are systems which cannot exchange energy at all. Now, just to check whether you understood the concept. Okay, so what are the three systems? Some systems can exchange both energy and matter. That's mass, right? Matter. Then some systems can exchange only energy. Some can't exchange both. Mohud bhai. Okay. So if I take this water bottle as a system, if I name these as 1, 2, 3, to which type of a system this belongs? Itala again. Is it 1? Is it 2 or is it 3? This is just a regular water bottle. I have closed the lid. Now this system belongs to 1, 2 or 3. I want answers from everyone. Everyone try to answer, right? It's not only about 2 or 3 students answering for all the questions. I want everyone to answer. Doesn't matter, I won't read your answers. I just want to see messages coming. That's it. And answers, right? Is it 2 or is it 3? Is it 3 or what? No, and answers and always try to interact with me. Especially mata kammeli inda. Hari oara kammeli unnan kamanne just make sure that I am not bored. Hari pavunama. Good. Then for the students who said that it's 2, some students said that it's 2. It can only exchange energy. Then if I open the lid, what will happen? Then this system, see now when I close the lid, this is the system. So this is the boundary. This area is the boundary, right? Is it clear? But when I open the lid, now this is the boundary. It's a separate one, right? Now this is the boundary. It's an entirely different system. Now to what system does this belong? To what system does this belong? Did you understand the difference? Now this system, right? Can this system exchange mass? No, it can't, right? It can't exchange mass. Why? Because if I try to exchange mass, it won't. Simply, we assume that the evaporation doesn't happen for the moment. It's just an assumption, thinking that this bottle has been sealed properly. Then you can't take the water out, right? Then it will only exchange energy. How does it exchange energy? Can you explain how does this exchange energy? If you try to heat it, then the water inside the bottle will be hot. If you try to cool it down, then the water in the bottle will cool it down, which means the heat will be flowing in and out, which means the energy is exchanged. Now, even though the topic is energy, in this unit we are only interested about the heat energy or the thermal energy, the thermal energy. Therefore, we are only thinking about whether the temperature can be increased or whether it can be decreased, or simply it can be increased or decreased. Therefore, this system will belong to a system which can only exchange energy. But if I open the lid, then you can easily spill out the water, then it will be exchanging matter and it will also be exchanging energy definitely. Then can someone give me an example for a system which doesn't exchange energy or which doesn't exchange matter? දෙකම exchange කරන්න නැති එකකට example like can someone give me? There's a special bottle. When it's closed, it won't exchange matter. Also, it won't exchange thermal energy. What's that bottle? Yeah, that's the flask. Or the vacuum flask. It's the flask. In a flask, for a significant amount of time, the temperature also won't be increased or decreased, which means the energy won't be exchanged. Also, the matter won't be exchanged definitely when the lid is closed. Therefore, you can understand there are three types of systems. Now you need to know, now you have a proper idea. It's not just studying that this is a system, these are the systems. Now you practically know which type of a system is what. Now you can explain your friend, look, there's a system like this, that's like an open bottle. Or explain karanna puluwan it logically. That's what I want. Hari. Then a system which can exchange both is known as an open system. A system which cannot exchange matter but can exchange energy is known as a closed system. And then a system which can not exchange anything, which can't exchange anything, is known as an isolated system. Makes sense, right? Isolated කියන්නේ not interacting with anyone. පැත්තකට ලපාඩු ඉන්නවා වගේ එකක් නේ. So therefore it makes sense. Is that clear? Now these are the three systems. Now what I want you to do is, under types of systems, write down the three topics, put a small dash and explain what each term means, and if you want you can write an example. Now for the open system, it's a normal water bottle which the lid is open. Closed system, a normal water bottle which the lid is closed. Isolated system, a vacuum flask which the lid is closed. Water bottle again which the lid is closed. Before that you need to write the definition. Can exchange energy and matter through the boundary. We are interested only about that, right? Now this is the system. It should be able to exchange energy and matter across this boundary. That's what we are interested about. Can exchange energy but not matter. Cannot exchange anything. You need to write the definition and then quickly write examples. I'll give you 1 minute. Don't just try to copy the board. Always think and write. Go. That's the second subtopic. Hari. What system does open flask belong? Then anything there's not a, if the flask is open, if the lid is open, then it will either always exchange matter and the heat can be also flown through that opening. Therefore it will be an opening system. If the flask is open, it's similar to open water bottle, then it won't function properly. Then it will be an open system. Hari. Tagamu ragga. I'll give you 1 more minute. Taggala liyemu. හරි so what's the example for isolated system? A closed vacuum flask, a closed vacuum flask, an open water bottle, closed water bottle, closed vacuum flask. Yeah, thermos flask. අවුලන්න even flask is shape ඉතින් hot water flask doesn't matter the first term, it's just the idea ne doesn't matter. Is it clear? Harne avulak naha, right? Then now this is actually one category. Now we can divide systems considering their energy or matter exchange across the boundary, and that's one definition. Accordingly we can get three types of systems. This is one categorization. On our syllabus there's another categorization. Under that we have two systems. One is homogeneous system. One is homogeneous system. And another one is heterogeneous system. NEOUS. Hari. Now what's the difference? Now here, these two have no relationship, right? May they entirely different. This is according to one requirement or one, let's say, definition. Now this is defined according to another definition. Under this definition we are checking all the matters inside a system. Now let's say if you are considering this system, and this is the boundary. Inside this system we only have liquids, therefore we can't consider this system. This is not a proper system. Let's say I added a little bit of coconut oil into this system. Now I open the lid and I add little bit of coconut oil and then I close the system. Then inside this system I have water and then coconut oil. Both are liquids. Then that will belong to a homogeneous system. Then that will be a homogeneous system. So simply we are considering all the substances or all the matters in a system. If all the matters belong to the same physical state, either a liquid or a solid or a gas, then that will be known as a homogeneous system. If not, it will be known as a heterogeneous system. For an example, if I open the lid and if I add some powder, let's say I add some powder, then inside this there will be liquids and then there will be solids. Then that will belong to a heterogeneous system. Simple as that. Is it clear? We consider all the matters in a system. If all the matters belong to the same type, same physical type, not same type, same physical state. The proper word is same physical state, which is liquid, gas or solid. Then that will be known as a homogeneous system. If not, that's a heterogeneous system. So that's a second categorization. So this is the first categorization. You can keep those three aside, keep few rules, and then the second categorization, considering the physical states, you can write the first type is homogeneous, the second type is heterogeneous system. Okay, under that you can write, you can write on your own. If all the matter in a system has the same physical state, then the system is homogeneous. If not, heterogeneous. Normally we give a interval at 10. හරි. අහලා තියෙනවා interval තියනවාද කියලා at 10. හරි. enough time. අන්නේ shape නේ. හරි. That's a question. All composition of a system is same physical. Yeah, that's it. Yeah. If all the matter in a system has the same physical state, then that's a homogeneous system. This is a heterogeneous system. If you want, you can write examples, but this is more. This is trivial. Ne? Teranan is obvious. No need to write examples. This is a water bottle which contains water and let's say coconut oil. This is a water bottle which contains water and then a stone. A stone. Then that's liquid and solid. Simple as that. So that's the end of the second subtopic. Now quickly I'll give you 1 minute. Go through what we have done. Mula inang enna. We started the unit, we defined systems. Can you remember the definitions? And then the theory might be simple, but we have to learn some amount of theory, then it will be confusing. Therefore check whether everything is okay. ප්‍රශ්න තියෙනවා නම් අහන්න. If not, I'll start the third topic. And a small thing, I actually forgot this. Or shall we do it separately? Yeah. For the gas laws, I promised to this class that I will do few more questions, because in my opinion it's better if we can do few more questions. For that I will be arranging a separate session. Even the new students can join if interested, and if you know the theory. If not, no point. I'll inform the details on the group. Hari. So the new students can ignore it if you want, but there will be a separate question discussion session or a revise session which the program will be informed on this week. Hari, is it clear? Then on that we will revise the theory and do few questions. Hari. But today I'll take the final 5 minutes to explain. If you can remember that Z is higher than 1 and Z is lower than 1 part, I told you that I'll explain it again. For that part I'll take the final 5 minutes. So normally we finish at 11:15, then I'll do it from 11:05 to 11:15. Okay, I'll explain this part again. Is it clear? Because I think I couldn't do it properly previous week, therefore I'll do it. So the new students can leave at this time, but the others can stay until 11:15. We'll have a separate session to do few more questions which I'll inform on the group later. Hari? Right. There's a question. In the resource book it is mentioned immiscible liquid as an example for heterogeneous system. Good question. Yeah, I'll explain it later. That's a good question actually. So then that example which I gave doesn't match according to the resource book. That's a good question. Now, if the liquids are immiscible, which means if the liquids can't, which the liquids don't mix, then it is defined as a heterogeneous system. That's a different concept. I'll explain that later. Hari, on today's before today ending today, today's session, I'll explain that. That's a good question. හොඳ ප්‍රශ්නයක්. හොඳයි එක පෙන්නපු එක. හරි. Okay. Then the third topic. The third topic can write properties of a system. Properties of a system. The third topic, properties of a system. Properties of a system. Properties of a system. Students, give me a minute. Hari. Now under properties we have two types of properties, and also other students also make sure that you have a resource book with you. No need to oftenly study the resource book, because I make sure everything is taught using the resource book. Now I myself also have the resource book. Manga resource I don't know whether it's clear, but I have the resource with me. I'm always referring to the resource because the resource book makes continuous changes. Therefore, make sure that you have the latest version. Now for each and every book, the latest version is different. The year is different. Now for this one, I think I have the 2021 book, but that's not the latest one. I am aware of the changes, therefore it's not an issue. But always when you are buying one, make sure that you have the latest version. You can buy it from the NIE, or I don't know whether the updated version is on the NIE site. You can check. It should be somewhere around 2023 or 2024. If someone has a latest version for this book, can you confirm? I think it's 2024. Yeah, it's 2024. Always try to have a resource book. The importance of having a resource book is, what's the importance? It's just have it. I don't know what's the importance, but just have it. Hari. Just have it, and yeah. For chemistry, for chemistry and bio, there's a proper. You can use the resource book properly, but for maths and physics, I don't know whether it's important. But especially for chemistry and bio, have the resource books. No need to buy the entire set, but at least try to buy few books here and there, and then with time try to complete the entire set. Hari. ගොඩක් ගණනුත් නැහැ. Properties of a system. Hari. Then under properties of system, not only in chemistry but in all the economics, in every system, the properties will be divided into two parts, which is macroscopic and microscopic properties. If you have heard the terms macroeconomics, microeconomics, it has something to do with the size. Now here, what's macro? What's the difference? What do you know about macro and micro? What's the general idea? මොකද macro and micro කියන එකේ general idea එක? Can see with naked eye, large and small. Yeah. Simply it's macro is large, micro is small, right? Then here it's macroscopic means you can easily measure a property by just getting a measurement. So simply you can just easily measure a property. If a property can be measured easily, then that property is considered as a macroscopic property. Now for an example, let's say you want to measure the water volume of this, the amount of water, the volume of water inside this bottle. What can you do? You can straight away put it into a, let's say, volumetric flask or even a beaker. If it has been properly numbered, then you can easily get the volume. If you want to measure the temperature of your body, you can easily get it measured. Is it clear? You get it measured. Then if you want to measure, let's say, the mass of a certain object, you can put it on a scale and then easily get it measured. But if you want to measure, let's say, I give you a balloon and tell you to measure the mass. You can measure it, right? You can use a electronic scale and then get it measured. But if I ask you to measure the speeds of gas molecules now in this balloon, you can measure the volume, you can measure the mass, you can do everything. But if I ask you to measure the speeds of these gas molecules, can you measure it easily? Can you measure it easily? No, you can't. How can you measure it? How are you going to measure it? Now the students who did the 4th unit needs to know how to measure this. How can we measure this? If you want to measure the speeds of gas molecules, or else considering this example, let's say in this water you have some ions. This is not distilled water, which means this water contains ions. If you drink distilled water continuously, which is the water in your lab, you will die, because you need some ion concentration which is given by drinking water. Right? Then this water contains ions. Then if I ask you to calculate the speeds, or it's known as the mobility, the velocities of these ions, can you calculate it? No, you can't calculate it directly. You can't calculate it. Even with a microscope, you can't calculate. You can't calculate the speed. You can see it, but you can't calculate the speed. Then how are you supposed to do it? Any answers from your previous lesson knowledge? Any opinions? Now, if that cannot be calculated directly using a measuring instrument, what can we do? Now I want the velocity of this. Let's say it's C1, this is C2, this is C3. Okay, I want the values of these. How can I get it? Answers in. Now I gave this C as a hint. C you need to remember this C. Where was the C? Hitan. Answers did. Yeah, good. These things are really small, therefore you can't measure it directly, then you need to measure it indirectly. Measuring it indirectly means there are equations which have been derived by doing experiments. Then there are equations, you need to substitute for those equations. This is the molecular kinetic equation. Students who have completed the 4th unit knows this equation. This is the average velocity of a gas sample. Not the average, it's known as the mean square velocity. It's a different term, it's a definition. Somehow it gives the idea of velocities. Then if you know the pressure, this is a macroscopic, you can measure it directly. This is the volume, this is a macroscopic, you can measure it directly. These are masses, this is the mass of a sample, so you can measure it directly. This product is the mass of a sample, you know that, right? The students who completed the theory. Therefore, these three can be measured directly. These are macroscopic numbers, these are macroscopic properties. Then indirectly you can derive the answer for the microscopic property. So the simple definition is, now the general idea when you say it's macroscopic and microscopic, this is very large, this is very small, but that's not enough. You can't define what's small, what's big. It's relative. Small, it's relative. Therefore, you need to add that part which says if it is a macroscopic property, you need to be able to measure it directly, get the value of the measurement directly, but here you need to get it indirectly, especially using equations. Hari, that's the idea. Is it clear? So defining macroscopic properties, you need to mention two things. The scale is large. The scale is large. Don't write the scale is macro, then again you are using the same word. It might sound nice, but don't write. The scale is large. You can directly measure. The scale is small, or you can write the scale is atomic, which is again small. Podi කියන එක, පරමාණුක කියන එක. The scale is atomic or small, and it should be measured indirectly. Can you write it on your own? පුළුවන් නේද? Alright, under properties of a system, put 1 or put A or whatever, put a star mark. The first property is macroscopic properties. Under that, write first write microscopic. There's a reason for that, you will understand, because we have to continue macroscopic later. Therefore, start here, start from this one. Start from microscopic. Under that, two points. The property is small, or the scale of the property is atomic or small, needs to be measured indirectly. The measurements need to be taken indirectly. That's the first thing. And under macroscopic properties, the scale is larger and the measurements can be given or taken directly. So first write this, then write this. When you are done, put it in the chat. එක්කෙනෙක් දැම්මම ඇති ඉතින් කවුරු එක්කෙනෙක් දාන්නකෝ when you are done. Done. Good. Others also quickly write it down. Microscopic කියලා මේ points දෙක ලියන්න. Macroscopic is the opposite of that. හරි? ඉදි නෑනේ. Still you have the energy නේ. හවුලක් නෑනේ. ප්‍රශ්නයක් නෑනේ. Right. හරි. How many days do we have for our A levels? කොච්චර තියෙනවද? How many days? දන්නේ නැද්ද? A lot. No? You don't have a lot. Any answers? You don't know? No, not for 25, for 26. No, you are 26 students, ne? Like 17 months. No. I know. I want the exact answer, not like 17 months. So you don't count the number of days. You don't have a countdown. Have one. Just for fun, thing. Just for fun, have a countdown. Not for fun. It will always make you feel some sort of a nervous. Podi nervous gatiyak kemei. Then you have a chance of actually working. It's 530. 516 now, okay. Is it a lot? 516 I have a lot. It's a lot. I don't want to work out of that 516, always minus the last 90 days, which is minus the last 90 days. Always reduce this. Why? If you haven't achieved a certain level in the final 90 days, believe me, you can't do anything. You can't do anything. Hari, anything at all. Now, 25 students also, I have said this. You can't do anything because you will feel the pressure, you will feel the stress. It's a different scenario then. But if you have done up to something, if you have achieved a certain level, then you will be really motivated. Okay, this is the final 90 days. Then there will be the adrenaline rush. Everything will be happening in your favor. If you have achieved a certain level, but let's say if you have 3 S's or let's say S and 2 C's when you have 90 days left, then it will be a really demotivating factor. Even for it's not 536, it's 426 minus 90. Yeah, okay. Then always make sure, I don't know what result you want. In my opinion, all the 26 students or even the 25 students who are here should have the aim to get 3 A's. Doesn't matter whether they want 3 A's or not. That's a difference. Or there might be students who are not willing to go for government units, who might be going abroad, who might go for a private uni, or who might do their own business or family business. Doesn't matter. 3 A's gone. Right? Always try to get the best result. Then you will get something. Right? That's the concept. Therefore, if you want to get 3 A's, I'll always aim for 3 A's. That's why we have a 50% A pass ratio of a classes. Then, if you aim for 3 A's, by the time you have 90 days left, at least you need to have 3 B's. Then you can get this. Even 2 B's, 1 C can be. Doesn't make a risky pod. When you have 90 days left, it's possible. It's really possible. Always make sure that you follow theory properly. Always complete the tudes. when we start writing papers, write papers regularly on a regular basis. When I tell you to do past paper questions, do past papers. When I ask you to join special sessions, join special sessions. If you do what I say, that's it. It's right. Term test එක පිළිවෙලට ලියලා අනිවාර්යෙන් ඔයාලට ඒ තුනක් එනවා. It's that easy, but most of the students fail to do this, therefore they won't get 3A's. That's why the 3A percentage is very low. What's the 3A percentage? Have I said this previously? මම බය කරන්න කියනෝ නෙමෙයි. I just want you to know the reality. What's the 3A percentage? කීය 3A percentage? Yeah, it's 2%. It's 2 to 3%. It's 2 to 3%. හරි මේක මම කලින් කියලා තියෙනවා in previous classes. It's 2 to 3%. For maths, I think it's 3.5%. For bio, it's I think 2.5% again. It's not 1, it's a little bit higher than that. It's something around 2 to 3%. Which means if 80,000 students are writing A levels each year, 40,000 roughly for maths and 40,000 for bio, then out of 80,000, 2% is 1,600 again. හරි ඒ වගේ ගානකට තමයි 2 ways එන්නේ. What's the 3F percentage? Can you remember what's the 3F? 3F percentage එක මොකක්ද? What's the 3F percentage? Failing all 3 subjects. What's the percentage? No, not 40. It's a fail. It's one that the 40 is the 1F percentage. For 40% of students fail at least one subject. So considering the entire scale or the entire scope of Sri Lanka, even getting 3S is a good result, right? So because 40% of students fail at least one subject, then that's failing A level, right? What's the 3F percentage? It's 18%. So roughly 1/5 of the students fail all 3 subjects. That's because simply they do not follow the proper instructions, not because the A levels are difficult. Now, if you have let's say brothers and sisters who are attending for universities, especially who are doing difficult degree programs, then ask them A levels is nothing. I'm being honest, right? මෙහෙමයි ඒගොල්ලන්ට සමහර විට they might not feel the university pressure because the competition is less in university. There's no competition. I want to get more marks than the other person. Hey man, if everyone does the exam properly, then everyone will be passed. Everyone will get the first class or the second class or whatever. Hari, in A levels there's a competition. If everyone gets a good result, then there will be again a cut-off. Then some will again not have the chance to go for uni. Therefore there's a competition. Other than that, campus level exams are very difficult then. Sorry, never I think now. The O levels were difficult than scholarship. A levels are difficult than O levels. Then uni should be difficult than A levels, right? ඊට පස්සේ masters කරද්දී ඒක difficult වෙන්න ඕනේ campus එකට වඩා. එහෙම නේ ඒකේ levels යන්නේ. Therefore it's not difficult. The point is that you fail to work 2.5 years continuously. O levels වගේ කරන්න හදනවා. You try to work for 3 months here and there and then try to write the exam and then you will fail. That's it. Therefore understand the situation correctly, hari. Then work properly, then you can get a good result. Hari, always keep these things in mind. Always check whether you are on track always. Now that's why whenever I start a lesson, I always give you a proper introduction without just straight away getting into theory. I explain where are we going to be, by what time, and what is our plan, when are we starting papers, everything I tell you. And even when I'm starting a unit, I tell this is physical chemistry, this will be done for 6 or 7 weeks. ඔක්කොම idea එක දෙනවා. It's not just now okay it's energetic unit 5 start. එහෙම නෙමෙයි. That's just showing you how to analyze, so how to assess yourself. ඒක තමයි මම මේ කරන්නේ. And always before I start a class, I always check whether I'm on track. Now if I promise you to finish the unit in 7 days, hari, I will finish it in 7 days, and I always make sure whether I'm on track. For some reasons, if you can remember, we had a power cut in the middle of the 4th unit. Because of that, we missed roughly 1.5 hours වගේ. ඒකට තමයි අර extra session එකක් දාන්නේ to cover the questions which I want to do more questions. That's why I want to do more questions. I won't take it from another day because then we will not be on schedule. තේරෙනවද? අර එහෙම proper plan එකක් තියෙනවා until February next year for 25 classes this year August වගේ වෙනකම් plan එකක් තියෙනවා. For 26 I have a plan for next year February. ඒ වගේ you need to have a plan for yourself. Even for the 27 batch, even though we haven't started it yet, still if you have closely observed, we have a plan. අපි දැනුත් plan එකක් තියෙනවා. We have seminars for them, all level seminars, and once we start classes we have another plan. අර plan කරන එක උපරිමයට කරන්න. Because most of the students do not plan. They just continue the rat race. What is a rat race? Just continuing the exact same thing without improving. Roll up the get up in the morning, attend school, attend classes, do some homework, go to sleep. every student will do that. Then you won't have an advantage. You will just be a normal student, then you can't get a good result. Always assess yourself, always check whether you are improving. Hari? Always try to finish the tunes. You will have a significant advantage. I'll explain how to get a significant advantage later. It's just theory for the moment. But once I teach you those, you can get a good result. Hari? How many hours should we work per day? That depends actually. So when you are counting the hours which you are working, you should exclude the hours which you are attending for classes, because everyone attends to classes. Now if your class is 5 hours and then you consider that as I worked 5 hours, then that's not a proper calculation. You need to exclude the class work, the time which you are spending in a class. Now this 3 hours won't be I work 3 hours. It's a class. But I myself even excluded the time where I did homework of the class. Excluded class time, excluded class homework time. Then roughly 2 hours per day is enough. That's difficult, excluding all of these, then you have no time. Try to do 2 hours apart from those two exclusion. Try to do 2 hours, that's more than enough. Now if you can't do 2 hours every day, now let's assume today you go to school from 6 let's say 6 a.m. 6 a.m. to 2 p.m. Then you have a class, then you have this, then you can't work 2 hours. No need to work 2 hours. Then you can do these 2 hours in another day which you are free. Then on another day you can work for 4 hours. Is it clear? Is that enough until A levels? No, this is not enough until A levels. For the moment, for a 26 students, this is enough. When your A level approaches, when your A level is nearby, you stop attending school, the school will give holidays, then it's a different story. That's a different story. For the moment, for a student who is on a regular routine, who is on a regular schedule, who is attending school, then this is enough. I even had a few hours of studying in school as well on the free periods. Free period, no need to study, but if you have, let's say, 6 free periods and 2 periods which they work, for some schools this is the case. Now if they teach properly in school, then you can learn it, then no point, no problem. But if you have 6 free periods and 2 periods which they study, which they teach, then what you do in these 6 periods is you just out, play, then you are very tired, you don't properly focus in your classes as well, then it's a waste. What I did was I had roughly 3 productive periods and 3 entertaining periods. Then it's balanced. No need to study in the entertaining periods as well. If you have free periods, enjoy, that's fine. But always make sure that you have a proper balance. Because A level, you can't work for A levels like this. You can't improve. It should be a continuous basis. It's something like this. That's the difference. That's the main difference comparing A levels and O levels. Is it clear? Therefore, make sure that those things are maintained. That's the most important thing. Then you will improve very quickly. You will very quickly realize that there are students who weren't that good, who were average in O levels, but now who are slightly improving. When I did my A levels in 2020, in our A levels, roughly 3 or 4 students out of the top 10 Colombo district students were average students. One student, I can remember, I can't remember the exact district rank. I think he was my one student from my school. I think Colombo district 6th. Yes, Colombo district 6th. In grade 9, we were in the same class. In grade 9 or 8, we were in the same class. I was the class first. I was the class first, and we had, I think, 40 students. He was the 38th student of the class. Again, he didn't actually work. 38th when for an average student, it's difficult to become the 38th. You get the idea. Therefore, this was the rank for in grade 8 or 9, I can't remember. But he ended up being the Colombo district 6th for maths. I ended up being only the Colombo district 35th. That's a good result, but you get the idea. The difference is that he didn't work for O levels, but when A level started, I didn't work when A level started. I was just chilling. Continuously he worked. That's the difference. Do we really need to get 80% attendance for A-levels? කොහොමද ඔයාලට උත්තර දෙන්නේ? Ask that on WhatsApp. I won't answer it here. That's a controversial topic, ne? It depends. It's a case by case scenario depending on your school. I can't say a yes or a no. I'll answer that if you ask it on WhatsApp. Hari? That's a good question. It depends. It depends. It's a very controversial topic. Hari? නැත්තම් මේ ක්ලාස් එකේ කිව්ව ඉස්කෝලේ යන්න එපා වගේ එකක් නේ. එහෙම නෑ හරි. If your school teaches properly, then you should definitely attend school and you should definitely write term tests, right? It's really important. The reason is that in paper classes we do write papers, but you won't get the same experience with all your friends in a same class. So the closest experience for your A-levels will be your term test. We can't match it. In a class, we can't match it. We can claim that we are matching it during our paper class, but that's not the truth. Therefore, students have issues. Term test papers are too difficult. They have out of syllabus questions. Doesn't matter. Just write the term test. That's it. Regarding attending school, that's a different topic. That depends on highly depends on what sort of a student you are and what school you are attending. So if you have that issue, you can ask later. Right. Then let's continue. We'll continue for 20 more minutes and have a small interval. Hari? Yeah, sure. Then Arnel, where were we? Right. Okay. Now we learned about macroscopic. What's happening? No. Right. Okay. Good. Everything is good. Hi. We learned about two properties, microscopic properties and macroscopic properties. Ne? Okay. Now, I told you to write microscopic properties first and then macroscopic properties. The reason is we need to continue macroscopic properties. These macroscopic properties can be divided into two parts. Macroscopic properties can be divided into two more parts. This is one of the most common questions asked under the energetic unit. Right? For macroscopic properties, the first part will be extensive properties. The other part will be intensive properties. Extensive properties and intensive properties. Is it clear? The definition is, if a property is an intensive property, the value won't change or won't depend on the size of the system. I'll explain it later. The value is independent from the size of the system. Right? Size of the system. So this is dependent. This is dependent from the size of the system. Is it clear? Is it okay? Now this is independent and this is dependent from the size of the system. Now if I try to explain this, tell me how can I explain it? Let's write few macroscopic properties and try to divide it into extensive or intensive depending on the definition. Hari? Tell me few macroscopic properties. Macroscopic properties looking at the definition, simply the properties which you can measure directly. Afterwards we have to write few examples for microscopic. We didn't write ne pasalimu. Then for macroscopic properties, give me few examples. What are the examples? Okay, mass. Good. Mass. What else? Mass. Volume. Okay. Pressure. Interesting one. Then temperature. Okay. Then what else? Any other answers? Any other properties? Hari මේ ටික ඇති කියමුද දැනට? Okay. Moles, number of moles, yeah, that's also a macroscopic property. Concentration, all are macroscopic property. Now you might wonder that can you calculate the number of moles directly? Isn't it N equals MOM? That's how you know, ne? You can actually calculate it directly. It's something related to the macroscopic scale of a system. Even the concentration, you can directly, now even in the lab, the concentrations are clearly written, so it's easy to calculation. It should easy to calculate. It should be easy, right? Amaruwa wenna bane. Okay. Then this concentration, number of moles, yeah, correct. Those answers can be accepted. Hi. Then we are going to divide these into extensive and intensive. After this division, we'll have a small interval. Hari. Then let's take the water bottle. Where is it? If you take the water bottle, if you consider the water bottle, now value is independent from the size of the system. Simply, the easiest way to memorize or easiest way to understand whether a property is extensive or intensive, assume a bottle which is full of water. Assume a bottle which is full of water. Now, if I cut the bottle in half, if I cut the bottle, now assume the bottle is filled, this is filled now, right? If I cut the bottle in half, then, and I cut the bottle in half and I consider one half. I only consider one half, right? Now considering that one half, did I change the size of the system? Of course I changed, right? I cut it in half and took only one half, which means I changed the size of the system. Is it clear? I changed the size of the system. That's clear. Then what will change? Will the mass of the system change? Yes or no? Now what's the system? It's not the bottle, right? The water inside the bottle is the system, right? If you can remember. Now you need to be clear with your definition. Now this is not the system. What is this? The bottle is what? Is the bottle system? No, what's the bottle? It's the boundary, right? It's not the system. So what's inside the bottle is the system. The water is the system. Is it clear? There are no definitions. Now the definition might be obvious, but most of the students I know were thinking that bottle is the system. It's not the system. It's the boundary. What is inside is the system. Sorry. Now when you cut the bottle in half, then the system will be divided into two parts. The top part and the bottom part. So I will only consider one part. Then did I change the size of the system? Yes, of course I did. Okay. Then did the mass of the system change? Yes or no? Everyone try to answer. Simplify right? Did the mass change? Yes or no? I cut the bottle and I'm only considering one half, right? I'm only considering one half. Because if I consider both halves, then the system has not changed. I only consider one half. Then did the mass change? Of course, the mass changed, right? Why? Now only if we had 500 milliliters, now we have 250 milliliters. Therefore, the mass changed. Change whichever api use karamu red color. C changed. When I cut the bottle in half, will the volume change? Will the volume change? We are talking about water. The volume of water change, of course. Then it's right. Pressure podda kamata karanna, it's a difficult one. We'll talk about that later. It's a difficult one. Hari. When I cut the bottle in half, will the temperature change? Did the temperature change? Now, if the temperature was 25, when I cut the bottle, will it be 50? No, it's 25, right? If nothing happens, if we assume that due to the cutting process nothing happens, then the temperature won't change. Therefore, this didn't change. Then not change here. Not change. Okay. Concentration will product because for water no need, we can't consider concentration. It's just water. Number of moles, will it change? If I cut the bottle in half, will the number of moles change? Yes, of course. The number of moles will change, right? It will change. Right. Then since you have given the property concentration, let's say that I filled the bottle partially with water. Now this is a separate story. I filled the bottle up from with water up to this point, and then I added few let's say few grams of or few milliliters of cordial. I'm going to prepare a cordial now. Hurry. Then I fill the bottle up to this point, then I add cordial and then I properly stir it and then I make a homogeneous solution of cordial. Now this bottle is entirely filled with cordial. This bottle is entirely filled with cordial. Now if I cut the bottle in half, will the concentration of cordial change? Yes or no? Will the concentration of cordial change? No, it won't change, right? It's obvious. It won't change. Why? The number of moles of cordial in each half will change, but will the concentration change? No, it's similar everywhere, right? It's homogeneous. It's හැමතැනම එකයි. It won't change. Therefore, the concentration won't change. Is it clear? It's clear, right? Now, for another example, let's say in your lab you have a bottle of HCl which has written 1 mole per cubic decimeter HCl. You can write it as 1 capital M, 1 mole per cubic decimeter HCl. Now, if you take 5 drops of this, which means you are taking a different size of system. Now, this is the big system. Out of this big system, you are taking 5 drops and naming another system. You are defining another system. Will the concentration of HCl change? No, it won't change, right? The number of moles, the volume will change, but will the concentration change? No. Then how about density? How about density? Will it change? Let's again assume the bottle with water fully filled. If I cut it in half, will the density change in the remaining half? No, the density won't change, right? Now, do you understand on how to divide a system to whether it's dependent on the size or independent on the size? Is it clear? Therefore, now what we got was, for density, it won't change, right? For density, it won't change. It's not change. Not change. And for concentration, it's not change. Pressure difference story. Is it clear? Can you understand it properly? Is it clear? Is it okay? Is there anyone who wants another explanation, or is it perfectly okay? Podi confirmation it's okay, right? I didn't fully understand how to differentiate macro and micro. Okay, okay, I'll answer that later. For the moment, if you consider that density is macro, do you understand this concept, intensive and extensive thing? Is it okay? Now, understanding macro and micro might not be 100% okay, because we know a very small amount of things. Now, according to my definition of the measurements can be taken directly, you might be thinking how to take density directly, then how can it be macro? That's perfectly okay, right? Because we don't know all the methods of measuring, right? Now, for you, measuring the mass directly makes sense. Measuring the volume directly makes sense, but measuring the density directly doesn't make sense, right? But in university level, even not in university, in all levels also you had the method to measure the density directly, right? I can't remember the name. Physics you can what's the name of that? I can't remember. Hydrometer, yeah. The hydrometer, using the hydrometer, you can directly get the density, right? So then it's macro. Therefore, for some properties, they might not recall a way of directly measuring, but those are macro. That's simply because you don't know whether they can be measured directly. Did that answer the question? Therefore, that's macro, because density can be directly measured using the hydrometer. Hydrometer, it will read the density. Right, good. So the only reason for not understanding macro and micro should be that you don't know whether it can be measured directly. Therefore, just believe what I say. If I say this is macro, that's macro. Therefore, once you understand what is macro, can you easily divide it? Now, if it is dependent, if a property is dependent, then when you change the size of the system, the property will change. Therefore, that will be extensive. Now, mass will be extensive. Why? Because you cut it in half, the mass will change. Volume will be extensive. Why? Because if you cut it in half, then it will change. This is extensive, this is extensive, this is extensive. But when you cut it in half, if the property doesn't change, then the value is independent from the size, which means it is intensive. Temperature didn't change, concentration didn't change, density didn't change. hear me now, right? Sorry. Okay, thanks. Hi. Now, what I was saying, simply that since you can understand whether the property will change, the value of the property will change depending on the system of the size, you can say whether it's extensive or intensive. So if it is independent, which means if the size doesn't affect the property, for an example density, by changing the size of the system the density won't change, therefore it's independent, then it's intensive. If it is changing like mass, when you change the size of the property it will change, therefore it's extensive. So you can simply divide it. Now first we'll write the definition and then we'll divide it into two parts. Sorry, under macroscopic write macroscopic properties of a system. Macroscopic properties of a system. Macroscopic properties of a system can be divided into two parts. Can be divided into two parts. Can be divided to two parts. First extensive, right? Extensive. First extensive. Value of the property, under that you can write under extensive, value of the property is dependent value of the property is dependent, or value of the property depends from the size of the system, or on the size of the system. Under extensive, right? We are writing extensive. C and N for extensive. The value of the property depends on the size of the system. So for intensive, you can write value. Before writing intensive, keep a few rules to write examples. Then you can write intensive and then write the definition. We'll write examples later. Right? First write the definitions. First write the definitions. Okay. Then there's a question. Could you please repeat definition? Okay. For intensive, value of the property is independent on the size of the system. Value of the property is independent from the size of the system. Value of the property is independent from the size of the system. That's intensive. For extensive, value of the property is dependent from the size of the system. It's clear, right? Then it's almost 10. We'll take a small interval. We'll start at 10 minutes past 10. Hari? Afterwards, before joining, if you want, you can, if you remember what I taught, you can write the examples. Hari? If not, you can write it after, explain it again. Then we'll continue from there onwards. Sorry, we are in the middle of theory. So if you want, you can leave the meeting and rejoin, but rejoin on time. If not, you can stay on the meeting. Doesn't matter. Right? And if you have questions, put it in the chat. Right. Then we'll continue for 1 more hour. I'll actually finish I'll give the interval at 10. I'll actually finish at 11:05, and then from 11:05 to 11:15, I'll do that gas loss part. So then new students can leave. Right? So we have 55 minutes, okay, roughly, for the today's session. Right? Right, can you hear me? Okay, then let's continue. I gave you a few more extra minutes and we have roughly 45 minutes. Yeah. Alright. Then we'll quickly finish what we were doing. So we have written down the definitions for extensive and intensive properties under macroscopic, and before that interval එක ඉවර වුණාට පස්සේ check whether your focus is you have the proper focus. හරි. interval එකේ වෙච්ච දේවල් වැඩක් නැහැ. Now you need to focus. හරි. And now you know what's macroscopic, you know how it can be divided into two specific parts, and you know the definitions, and you have a better understanding even than the definition, right? Definition is just a definition, but you need to be able to divide it into two parts. That they normally won't ask the definitions. They will normally ask, they will give few properties and then ask you to divide it into two sections. Right? That's how A level works. Then what I want you to do is, you can either, it depends, if you want you can write the examples for extensive under that part and intensive under that part, or else you can draw a small table and then divide it. I'll do it like that. It's up to you, right? Doesn't matter. Extensive on this side, intensive on this side. Hari? Extensive on this side and intensive on the other side. So what's extensive? Extensive is it's dependent. And here it's independent. Hari? It's independent. Is it clear? Then so I'll write down the properties which I expect you to divide: mass, volume, temperature, then what did we have? Density, what else? Pressure we will do it later. Concentration, number of moles, that's it. Concentration, number of moles, enough, shape, okay. Now what I want you to do is, I want you to divide these into the extensive and intensive part. If you feel that you will forget how I explained how to divide it into intensive or extensive, you can write the example which I gave you as a side note. May pathing podier as a side note, right? Now let's say you want to explain the procedure I told you. Now even though you remember it now, you might forget it later. Then what you want to do is, as a side note, right? Considering mass, assume a bottle which is full of water. Then if you cut it in half and consider one half, which changes the size of the system, then the mass of the system will change. Therefore, mass depends on the size of the system, then mass is extensive. So for each and every property, you can use the example. For most of the properties, you can use the example bottle filled with water. So you can write that explanation as a side note, but I won't give, that's not a theory point. It's just a method which I taught you to understand. If you want, you can write it as a side note. It's up to you. If you want me to repeat, I can repeat. Then using that thought procedure, try to divide this into extensive and intensive quickly. Now I taught you this procedure, then you need not to remember whether it's extensive or intensive. You can derive it when it's given in your paper, when it asked on your paper. Can you explain how the density became? Okay, I'll explain how density became intensive. That question was asked previously as well, I guess. I'll explain that. Apart from that, write down everything. So we have pressure as well. I'll explain pressure also, what happens to pressure. I'll give you 1 minute, then once everyone is done, I'll explain density. Can you explain the bottle thing that you said to write as a side note? Okay, so what I said was that for mass now, if you want to remember, or if you want to write down the thinking process, you can write for mass. Now if you want to figure out whether mass is extensive or intensive, consider a bottle filled with water as the system. Then you cut it in half, which changes the size of the system. Then the mass of that system will change. Therefore, it depends on the size of the system, therefore it's extensive. But if you consider the temperature of the bottle after cutting it in half, it won't change. Therefore, the temperature property is independent from the size of the system. Then it's intensive. That's the thinking process. It's easy to think logically when you know an example which makes you easy to think. Ne? Hari. Right. දාගෙන යන්න බලන්න. I'll give you 1 minute. I have a few now. Some students are saying that they are done. So I'll give you a few more properties. Think about those as well. Hari, think about those. Boiling point. I'll give all the examples which are given on the resource. Melting point. Heat capacity. And then refractive index. Now if you don't know what's refractive index, you can keep it. Refractive index, divide what you know. Hari, refractive index, molar volume. We learned this in 4th unit as well. Surface tension, it's you can learn it later. No, I'll give it. It's on the resource, so I'll give it. Surface tension. You might not know how to think about it because you don't know what surface tension. Energy of the system. Energy can either be kinetic or potential energy. Doesn't matter. Any type of energy. Basically, it's kinetic or potential. Hari. Viscosity ඉතින් තව පොඩ්ඩක් තියෙනවා ඉතින්. ඔය ටික ඇති. Yeah. Enough. Quickly try to divide this, so I'll give you one තව පොඩ්ඩක් වෙලා දෙන්න because I gave you few more properties. Try to divide it into 2 parts. Enough? Did I give you enough time? Okay. Then shall we start dividing? Now listen, you might not be done, but listen. Now what is mass? If you want me to explain any property a little bit more, then you can ask, right? If not, since I have done the main explanation, I will just divide it. Hari? The mass, we know it's extensive. Mass is extensive. Volume changes when you cut the bottle in half, extensive. Temperature doesn't change, intensive. Temperature doesn't change, intensive. Number of moles will change when you cut the bottle in half, then it's extensive. That's easy. Melting points and boiling points, extensive or intensive? Ragal answered them. Melting points and boiling points, is it extensive or intensive? Yeah, it's intensive, right? It's obvious now. The melting point for water is 0. The boiling point for water is 100. It won't change depending on the size of the water, right? Then it's on the intensive side. Melting point. Write it properly. Write it melting point, boiling point properly. What else? Concentration. We discussed this, right? The concentration. Now, if you have a homogeneous solution, the concentration is equal everywhere. So, if you take few drops or if you take a portion of it, still the concentration will be the same. Therefore, it's intensive. If you want me to explain it, you can ask concentration. Then pressure is left. Okay. Heat capacity. Do you know what? Or else energy. What will happen to energy? Assume kinetic energy. What will happen if you change the size of the system? Consider kinetic energy. If you change the size of the system, what will happen? What will happen? Yeah, it's extensive, right? Why? Now, if you change the size of the system, now you know that kinetic energy is half mv squared. Potential energy is, you know these equations, right? O levels, nothing physics, mgh. If you change the size of the system, we understood that the mass will change. Then this will change. Therefore, the energy is what? Extensive. It will change. The energy will change depending on the size of the system. It's obvious, right? Now you can take any system. If you minimize or if you scale up the system, the energy will change accordingly. And energy is extensive. You can get an idea looking at the equations as well. When you change the system size, m will change definitely, then these will change. What else? Okay, now the difficult ones. What's refractive index? What will happen to refractive index? What do you know about refractive index? In O levels, have you learned in O levels about refractive index? What do you know about that? On refractive index. It won't change, right? Now, if you can't remember, doesn't matter. For the moment, you can just study because you haven't learned about these in A levels. But once you learn, you will understand. For the moment, since you don't know, just you can remember for the moment. Hari? Yeah. So for refractive index, you had equations, and also for water, it's a the refractive index of water is a constant. For glass, it's constant. It's 1.5, I guess. For water, it's 1.33. So those are constants. Those won't change. Therefore, it doesn't matter whether we have a lot of water or a little bit of water, still it's a constant. Then refractive index is on this side. It won't change. Refractive index. Hari? It won't change. Heat capacity, what about heat capacity? Heat capacity is the C in Q equals mc theta. It's specific heat capacity. Heat capacity is the capital C in Q equals C theta. What happens? Is heat capacity depend? It's intensive. Why? For water, if you can remember in all the questions, the specific heat capacity of water was 4,200 joules per kilogram per Kelvin. So this is a constant again for water. For each liquid, there's a specific heat capacity. Even the heat capacity are the heat capacity. The specific heat capacity is a, let's say, the specific heat capacity constant, but the heat capacity is not a constant. It depends on the size. Yeah, true. Right? Now here, the specific heat capacity is this. Specific heat capacity is, for water it's 4,200 joules per kilogram per Kelvin. This is the specific heat capacity is the C here. So it's a constant for water, for oil, for anything. But the heat capacity is the product of these two. Heat capacity is Q equals C theta. This one, this is heat capacity. Then it's the product of these two. Then when the system size is changed, M will change, then this will change, right? Is it clear? So to be clear, heat capacity will be extensive. It will depend on the size. Now this is an important point. In your term test, in A levels these things won't be asked, but in your term test this can be asked. Heat capacity is extensive because it involves mass. Heat capacity is the product of mass and specific heat capacity, therefore it's extensive. But the specific heat capacity is intensive. Check whether it's clear. Check whether it's clear. Hari? So I can't give you all the properties. You need to be able to figure it out. That's why I gave you the logic. You can write any side note. Not only the note. You can create your own note. It's up to you. We have no restrictions. Specific heat capacity. Hari. Then there's a question. Okay, I'll explain it again. But if we take 2 drops of not really. That's not true. Now there's a question. That's actually an interesting question. Now there's a question. Now I said that the concentration of a solution is, if it is homogeneous everywhere, it doesn't matter whether you consider one drop or 5 milliliters or a liter, right? Then there's a question saying if you take 2 drops of Sunquick, it will be lighter in color than a whole bottle. That's not true. That it's how you weave it. Oh, is it true? Is the intensity higher? I don't think it's not possible. Now you can think it the other way. Now assume that you have 1 liter of Sunquick and you have 5 liters of Sunquick. Can the intensities change, or is it the same? The colors are same, right? Then it should be same for even 2 drops. If you have properly mixed it. Now in practical circumstances, you can't get an exact homogeneous solution. That might be the issue. Or even when you have a small amount, you think it's light in color. It might not be. It's how it might be how you are weaving it. Theoretically, the intensity should be equal. Now here, because the intensity simply depends on concentration. If the concentration is similar, if it is exactly similar, then the intensity should be similar. It should be. So for 1 liter and 5 liter, the intensities are same. It should be applied when the scale is minimized. Same way. Hari, good question. Can you explain why heat capacity is extensive? Yeah, because heat capacity is the product. Now heat capacity is the product of specific heat capacity and mass. Then so the specific heat capacity is C, right? It's C here. It's defined per kilogram per Celsius. Then the heat capacity is the product of this, which is the product of specific heat capacity and mass. Then when you change the size of the system, will the mass change? Yes, it's extensive. Then when the mass change, this changes because it's the product of these two. That's why. Hare? No, specific heat capacity doesn't have mass. The heat capacity does. That's why. Here, heat capacity involves mass. This is C, this is MC. This involves mass, that's why it's extensive, but the specific heat capacity doesn't involve mass, that's why it's intensive. Is that clear? Did I make any confusion? හරි නේද ළමයි? කවුලක් නැහැ නේද? Is it clear? Is everyone okay with it or not? අහන්න ඕනේ නැත්තම්? Clear, right? Okay, good. Hari. There's a question again. What about the density, to which group that it belongs? Yeah, we did not do density, ne? We haven't done it yet. Wait. Okay, so now I'll erase what we have done. Anavashya I'll erase. We have to do pressure. We have to do density. These are okay. This is okay. This is okay. This is okay. This is okay. And also, since you don't know what surface tension, I just gave you because it's on the resource book, so simply they can ask it for your term test. That's why I gave you it. Hari. For surface tension, it's extensive. Sorry, intensive. You can just write it. You simply don't know what surface tension. Therefore, it's extensive. Sorry, intensive. It doesn't depend on the size of the system. Right? It doesn't depend. Hari, it doesn't depend. Hari, then we have molar volume, density and pressure. Hari. Before I continue, there are a few more questions. But heat capacity is C theta, right? No, it's not C theta, it's no. Heat here, it's MC. Now here, now if you can't remember physics, sorry, I'll explain. Go. Now, if we learn this in this unit as well later, now it's Q equals MC theta, right? M is mass, C is specific heat capacity, theta is the temperature difference. Q is the exchanged amount of heat. Then you have another equation which is Q equals C theta. Then this C is equal to this MC. Right? Then this C is the heat capacity. Hari. This is the specific heat capacity. Hari Devan. Right? Then, no, not this. This is the specific heat capacity. This entire thing is this, which is the heat capacity. Is it clear now? Therefore, heat capacity contains a M, but the specific heat capacity is just a constant for each and every liquid or the element or the whatever substance. Is it clear? How long that day? Or is it not? Okay, if it is not clear, just let me know, right? Put it on the or ask on WhatsApp later. Hurry. Then let's continue. Okay, we have density and we have pressure. Then we have molar volume. What else do we have? That's it, ne? Hurry. We have 3 more to be done. Hurry. Then tell me what's now students who did molar volume should be able to tell whether it's intensive or extensive. Is it intensive or it's extensive? Molar volume. What's molar volume? Volume of a gas for 1 mole. If we take 1 mole, the volume of that. Is it extensive or intensive? It's intensive. Why? Why is it intensive? Why is it intensive? Because simply doesn't matter, the sample size doesn't matter because molar volume is the volume of 1 mole. Doesn't matter whether the sample is 10 moles, 100 moles, 1000 moles, we are only considering 1 mole because it's molar volume. Now if it was more volume, then it depends on the size, because if the size increases then the volume increases, but here it's molar volume, it's the volume of 1. That's why. Therefore it's intensive. Check whether that's, now you can write a side note saying why it was intensive, because simply no matter what the sample size is, we are only interested about the volume of 1 mole. That's why. Therefore it's intensive. Alright. Molar volume is intensive. Then that's for volume. Then we have density, then we have pressure. What about density? Any answers for density? Again, use the same example. Use the bottle which is filled with water. What's the density of water? Now when I ask what's the density of water, will you ask me what's the sample size? Will you? Sample size but when I ask the mass of water, will you ask how much of water? Yes, you will ask, because the mass will depend on the sample size. But when I ask the density of water, you will say it's 1. It will change with temperature. Density will change with temperature, but are we interested? No. Why aren't we interested? Can someone explain? Now, someone can counter. How can you say density doesn't change? It will change with temperature. But we are not interested. Why? Why aren't we interested? Because we are simply interested about whether the sample size affects the property. Now, is temperature the sample size? It doesn't have any, it's not relevant here. Right? So, density changes with temperature, but we are not interested. We are only considering whether density changes with the sample size. Now, if you change the sample size, will the density of water change? No, it's still 1. Right? Therefore, it's intensive. Density is intensive. Now, it's up to you to write side notes if you want, right? Because now when I explain, you might understand this properly, but later you might not. You might struggle to figure out how density became actually intensive. So, if you want, you can write. Depends. If you take, so the density doesn't affect, the value of density won't change with the sample size. You can simply write it and you get the idea. Then density is done. What else do we have? We have pressure. This is difficult. So I'll explain pressure. Before explaining pressure, check whether everything is okay. Check whether everything is done. Everything is written properly. I'll give you 30 seconds. Okay, right? Done. Then we are going to understand whether pressure is intensive or extensive. Before I explain, I want you to give me answers on whether pressure is intensive or extensive, and always I want the explanation. It's not just whether it's extensive or intensive. Try to give an explanation, not just the answer. Try to give an explanation. Now we have roughly 30 minutes left, right? Now I know it might be a little bit hectic now, it's a little bit tiring now. Right, even I am tired, but we'll continue. Okay, try to give me answers whether it's intensive or extensive with explanation. I want explanations. Doesn't matter whether it's wrong or correct. Taggala denna balanna answers. Why? Not just the answer. I want explanations. Intensive because the pressure is equal at the same point. But that's not the sample size. H is not the sample size. And it's not always height for pressure. It's now you might be thinking P equals H rho G. That's why you might be saying it's something to do with height. The first thing is height is not the sample size, and this is only hydraulic pressure. Now if we consider the pressure of a gas, then you can't even use this equation. So that explanation is wrong. That's why I ask you to give me answers. Then I can show the what are the errors which you make when you are thinking. Eka godak important. It is ratio of force and area, just like good. That's a really good understanding. Okay. Other answers? That's the answer actually. Anyone else? Any more answers? The easiest way now, up to now, I explained whether a property is intensive or extensive simply using the practical understanding නේ. මෙතනට එනකන් අපි practically මොකක්ද වෙන්නේ කියලා හිතලා තමයි උත්තරේ ගත්තේ. Is it clear? We use the practical understanding. For mass, we took a practical example. For volume, we took a practical example. For temperature, the same. For pressure, it's little bit difficult to explain it in a practical way. I'll explain it later. But to conclude whether pressure is intensive or extensive, we'll use a concept. Hari, we are going to use a concept which was actually one answer. That's really good. Now let's try to learn that concept. Okay, what I'm going to do is pay close attention. Hari, pay close attention. Let's take volume and molar volume. Can someone explain why volume is extensive and why molar volume is intensive? Quickly, try to explain why volume is extensive and why molar volume is intensive. What's the reason? What's the difference? Now don't say that volume won't change with size and this is, then that's the definition. I want to know what made volume extensive but molar volume intensive. What change, what logical change made the difference? Can someone say? Sorry. Can someone explain? What is the logical difference? Okay. So, I'll give another example. Now, this is actually a couple. See whether you can see more couples. Now, this is a couple. Moles. Shall I use another color? Pattern on a couple. This and this is a couple. Try to understand what I am trying to say. Then this and this is a couple. Density. What might I suggest? Any answers? Even this one you can take as a couple, but that's not that obvious. This and this. Any idea on what I am trying to say? A certain ratio which is extensive, a certain property which is extensive, can be transformed to an intensive property by making a specific change. Can you try to understand that specific change? Okay, that's true, that's correct. The answer is correct, but I want to know, now these four extensive properties have undergone the same change, the same procedure to make it intensive. What's that procedure? By dividing by another extensive property. That might be true, but other than that, what have we done? What have we done exactly? Yeah, that's true. We have divided it by another extensive property. That's correct. But ultimately, what has happened? What has happened is we have defined all these ratios per single unit. Check whether that's understood. All of these ratios here have been defined per single unit when it comes to this side. Mass density is mass per unit volume, right? Volume, molar volume is volume per unit mole, correct, right? Moles Concentration is moles per unit volume. Heat capacity, specific heat capacity is heat capacity per unit mass. Check whether that's clear. What we have done is we have transformed these extensive properties in a way that we are only considering these properties, the same property, but per single unit. Therefore, from here onwards, the sample size doesn't matter. Why? Because we have fixed the sample size for 1. That's why. If you can understand that concept, then we can figure out whether pressure is intensive or extensive. That's the idea behind it. ඒක තමයි මේකේ පිටිපස්සේ තියෙන logic එක. That's the concept. හරි. Is that clear? Is it okay? Is it understood? Does anyone have any issues? මේක හිතන්න මොකක් හරි case එකක් තියෙනවද? Right? So shall we now okay. Using this theory, right? Using this theory, Hari, I'm asking you a question. Now energy is a what? Extensive property. Now if you want to make it an intensive property, what can you do? Using energy, tell me the intensive property of energy. Any answers? There can be several answers. For energy, tell me an intensive property. What can be for energy? What can be an intensive property? Is smaller energy intensive? Is smaller energy intensive? Energy of a mole, is it intensive? Energy of a mole. Now energy is extensive, is this intensive? Yes, that's intensive. Why? Now we have fixed the sample size for 1 mole. That's the idea. So you can easily, now on the resource book also this concept has been mentioned. You can easily convert extensive properties to intensive properties by dividing these by a certain property which makes the property fixed to 1 unit. Fixed to 1 unit. Is it clear? Is that clear? Shape neda, avulak neda. That might be a little bit complicated, but you should understand it. Hurry. Then, before defining the whether pressure is intensive or extensive, we'll write it separately because you need to understand this property. I can just give whether it's intensive or extensive. Put a star mark and write after the table. Put a star mark and write. Put a star mark and write. By defining an extensive property, it's on the resource book. If you want, you can check it later. By defining an extensive property, for a unit system, it doesn't matter, it can be unit area, it can be unit volume, it can be unit mass somehow. Hari? By defining an extensive property for a unit system, in brackets, so if you want, you can use for a unit system, for a unit volume, for a unit mass, for a unit, what else? Unit volume, unit mass, yeah. Doesn't matter, unit area, hari, oneka. By defining an extensive property for a unit system, in brackets, unit volume, unit area, unit mass, close brackets, it can be transformed to an intensive property. It can be transformed to an intensive property. It can be transformed to an intensive property. Sorry? It can be transformed to an intensive property. Now you can write examples. Mass, extensive. Mass per unit volume, intensive. So how you should write is, after writing the definition, under examples. Mass, extensive. Mass per unit volume, intensive. In brackets, write mass per unit volume is density. That's example number 1. Therenoda ලියන හැටි? Okay. Then here I have given you 4 examples like that. Volume, extensive. Volume per single mole or unit mole, intensive. In brackets, write it's smaller volume. Moles, extensive. moles per unit volume. Now you need to know the equations, right? It's concentration equals NOV ne? So it's per unit volume, it's defined by unit volume. Hari, if you want help you can ask. I hope you know, I expect you to know, right? Moles per unit volume. Moles is extensive, moles per unit volume is intensive, and in brackets, right, it's concentration. Heat capacity, extensive. Heat capacity per unit mass, intensive, which is known as the specific heat capacity. Hari, check whether you can write those 4 examples. After you write, I'll repeat. And under the topic, under the point which we wrote, put example and write those 4 examples. Liam Raggal. I'll give you 2 minutes. Guidance on nan kiyan. Ready? Is it clear? Do you want me to explain anything? Right. So you wrote 4 examples. I hope that you wrote all 4 examples. Guidance on because I won't give you notes. I always expect you to write notes. I always want you to think on how to construct the idea, because I give you the theory, I explain it logically, then I want you to write the answer. Then that's easy. Even it's easy for me. Then I don't need to explain it that much. I can simply give you the note, but then by just writing a note, you won't build the skill to write answers. Then you will have to train it again separately. But here we are doing it simultaneously. Then after writing all four, then we'll try to explain whether pressure is intensive or extensive. Using the equation pressure is equal to force over area, tell me whether it's intensive or extensive with the answer. Now you will be able to get it. Is it intensive or extensive? Now understand the concept which we learned here. Then tell me whether it's intensive or extensive with the answer, with the explanation. Tell me. මොකක්ද answer එක? Good. Now we are getting answers. කියන්න බලන්න අනිත් කට්ටිය. Others, is it intensive or is it extensive? Now what did we learn? If you define an extensive property to a unit system, which can be unit mass, unit area, unit volume, unit whatever, then it will be intensive because we are simply fixing it to one. Okay, අනිත් කට්ටිය, I want more answers. තව ඕනේ, මම තව මහන්සිලා ඉගෙනනවා, මට තව answers ඕනේ. Everyone try to give me answers. Okay, good. Okay, හැමෝම දැන් හැමෝගේම answers ඕනේ. කම්මැලිකමට ඉන්න බෑ. We have like 5 more minutes. තව විනාඩි 5යි. Good. Right now you get it. Now do you understand how easy it will become once you start to understand things logically other than just studying pressure is this? You will easily forget if you just studied whether pressure is intensive or extensive. Now I gave you the logical explanation. Now you can derive it by yourself. Now you can think whether force is intensive or extensive. First of all, you can easily understand if you change the size of the system, the force will change, right? Simply if you are holding this water bottle, if you cut it in half, then the mass will change, then the force will change because force is just m equals to the acceleration of it. Let's say it's m equals F equals mg, considering it's the gravitational acceleration, then g is a constant. Then if you change the system, then m will change, then F will change. Therefore, it's obvious that force is extensive. This is extensive. This is extensive. But this is defined per area, for a single unit, for a single area. When you divide it by A, this force will be defined for a unit area. Then pressure will be what? Intensive. Pressure will be intensive. It's much more easy to understand it rather explaining it. Trying to explain it using a practical system, using a balloon or using a hydraulic pressure system, it's much more easy. If you want, you can think it that way as well, but it will be difficult. Using a balloon to think, it's difficult. But you can, if you are interested, think. Then ask me questions. Hari? So you get the idea. Now, using this, I'll give you a question. Put a Q and write. Put a Q and write. We'll write this as a question. We normally put a Q when we are writing question. Then it's easy to find questions in our note. Put a Q and write. Using the concept, using the above concept, this one which we learned, using the above concept, explain why pressure is intensive. Explain why pressure is intensive. Using the above concept, explain why pressure is intensive. Using the above concept, explain why pressure is intensive. Hari? Why is it intensive? I'll repeat. Force is extensive. No need to explain why it is extensive. If you want, you can explain. That's easy. You can explain it. Simply, it's MA. When M changes, F changes. Therefore, it's extensive. But this force is defined per unit area. This force is defined per unit area. Since it is defined per unit system, according to the previous theory, it should be extensive because we are not bothering about the system size because it's defined for a unit area. Right. Check whether you can write it. Always write your answer in point form. Don't write paragraphs. Make it a practice to write it in point form. If you want me to repeat, tell. If not, toggle him. Hari? So can you explain it? Avulak naha neda? Okay, if you have doubts, ask. Hari, if not, that's it. Then before we end the session for today, I'll take few more minutes. Hari, podi velawak denna. We need to make. Okay, first of all, we did not write examples for microscopic properties. Quickly switch to that part. We wrote examples. Now we did a lot for macroscopic, but we didn't do anything for microscopic. Ne? You may have the microscopic. Is it here? Okay, here. Okay, under microscopic, we didn't write examples. So you can just write examples. Since you haven't done a lot regarding microscopic, they don't expect you to know a lot. Simply you can write kinetic energies of atoms. Under microscopic properties, you can write kinetic energy of atoms, velocities of atoms. That's it. They don't expect a lot in this part. Hari? Kinetic energies, now you have written the definition. Under that examples, kinetic energies of atoms and velocities of atoms. You can write both of those there. Hari? Is it okay? Hari, ekat hari. And after that, hari, ekat hari ne? Hari. And then another thing, I actually made an error which was pointed out by a student. Thank you for pointing out. That error was regarding the categorization of systems. Under this part, come to this point, homogeneous systems and heterogeneous systems. Etana mama waradduwa. Hari. Here on the definition, resource book ekේ චුට්ටක් විතර for both the definitions it's not consistent, but I cross checked. Therefore, the definition should be changed. It's not enough to consider a system as homogeneous. Not only having the same physical state is enough. The physical state should be uniform. The actual word is uniform. The physical states should be, the matters should be uniform, or the physical states should be uniform. Meaning of uniform is little bit vague. පොඩ ලොකු කතාවක් එක. But giving you the simplest idea which they expect you to know in your syllabus is, now let's consider a system. Hari, let's consider a system. මෙතන ගමු කමන්නේ. Now if a system has a solid and a liquid, it's obviously heterogeneous. අවුලක් නැහැනේ, because it's obviously different. It's heterogeneous. If a system has a solid and a gas, then it's again heterogeneous. If a system has a liquid and a gas, again it's heterogeneous. Obviously අවුලක් නැහැනේ. If you have different physical states, then it's definitely heterogeneous. But what I want to correct is that if a system has two liquids, it's not always homogeneous. That's that's the mistake I made. It says according to definition, the system should be uniform, or the physical states should be uniform, which means for two liquids, they have only defined uniformity for two liquids. They haven't defined it for either solids or liquids, therefore no need to know it, right? The uniformity of a physical property is a different concept which they haven't taught here. They have only defined it for liquids. For liquids, you just need to know if the liquids aren't properly mixing, or basically if the liquids are immiscible, then it will be considered as non-uniform. It's not uniform then. Is it clear? Therefore, it will be considered as heterogeneous. So you need to change the definition. For homogeneous, it should be the physical properties should be same but uniform, and also uniform. The physical properties should be same and uniform. For heterogeneous, either if the physical properties, sorry, not the physical properties, the physical states, physical states should be same and uniform. It's an N, right? Physical states should be same and uniform in order to be homogeneous. In order to be heterogeneous, it should either be uniform, not non-uniform, or it should either be different. තේරෙනවනේ ඒ දෙකම satisfy වෙන්නේ නැත්නම් it's heterogeneous. What are the two requirements? The physical state should be same and uniform. And uniform. Hari? To explain this concept, furthermore, you can write, because they have only defined the uniformity for liquids, you can write, consider a solution which contains two liquids. Right? Consider a solution which contains two liquids. Even though the physical states are same, if the two liquids are immiscible, then it's considered as a non-uniform solution, therefore it's heterogeneous. Can you write it on your own? Hari, now what I want you to do, I'll repeat it. I repeat it twice now. Under homogeneous, change the definition at this part. The physical state should be uniform. To explain it better, you can write, considering a solution with two liquids, even though the physical states are same, which are liquids, if the two liquids are immiscible, if the two liquids are immiscible, then it will considered as a non-uniform solution, therefore it's heterogeneous. Is it clear? Now for solids and gases, you don't need to know how to check whether it's uniform or not. It's only for liquids. I think that's clear. Hari? Okay, then that's it. And since we are behind schedule, I won't take that 10 minutes to cover the Z part. I will definitely do it on next week, or else if we schedule the extra session before next week, most probably we might. Then I'll explain that session at that part. It's just a 5 to 10 minutes concept, but since I have made a promise not to continue the class after 11:15, because most of you are attending school tomorrow. That's not healthy, and I normally act according to the promises. We'll finish the class for today, and then this part will be explained later, right? It's just a 5-minute thing. Apart from that, everything is done for the 4th unit. Hari. Then that's it for today, students. We'll finish the session, and if you are for the new students, if you are continuing the session, stay on the group, on the WhatsApp group. Everything will be informed, how to register to our website, how the payment should be made, and how the tudes are being delivered. Everything will be informed within the next few days or the next 1.5 weeks. Sorry. If you have any issues, if you want to cover previous lessons, if you want to get any recordings, also send a WhatsApp message to my number. Then I'll inform the procedure. Hari. Yeah. If you have any questions, you can ask. If not, you can leave. And then that's it for today. Thank you for joining. Hari, right. Right. Thank you.